In this question, we're adding a strong acid, hydrochloric acid, to a weak base, sodium formate. And we're told the pKa of the conjugate acid of our weak base, which is formic acid, with a pKa of 3.75. So let's start out by writing out what our reaction is. So we have our weak base, which is our sodium formate, and we add HCl, our strong acid, which will react completely. So this weak base is going to take the hydrogen from HCl to make our conjugate acid, which is formic acid, and we're also going to have a salt left over, which is just the sodium and the chlorine. So sodium chloride left over. Now, if I write out my rice table, so reaction, initial, change, equilibrium, I'm going to use moles in my ice table. So we know our initial moles of our weak base is 0.25, which is given in the question. We need to calculate the initial moles of HCl. We have 1 molar HCl, so 1 mole per liter, and we are adding 250 milliliters of it, which is 0.25 liters, and so that means that we have 0.25 moles of HCl initially that we are adding. So we have 0.25 moles of HCl. Now this strong acid is going to react as much as it possibly can, and so there are 0.25 moles of weak base and 0.25 moles of strong acid, so all of the strong acid can react, so we're going to have minus 0.25 moles here, which means that it will react with all of this weak conjugate base, so minus 0.25 moles. We start out with no weak acid, and so our change here is going to be that we are adding the 0.25 moles that have reacted. Same with the salt, although that won't affect our pH at all in the end. So if we look at equilibrium, we have 0 moles of our weak base, we have 0 moles left of our strong acid because it's all reacted, and so all we have is 0.25 moles of our weak acid. Now we have to start again with another ice table because what we have in this initial estimation is that we have all weak acid. We're in water, so we need to look at what happens when we have weak acid in water. So if I have this weak acid and it's in water, it is going to form an equilibrium, which makes its weak conjugate base and hydronium ion. So I write out another rice table, reaction, initial, change, and equilibrium. Because of course when we have weak acid, it's not going to all be weak acid. Some of it will react with that water, will have a little bit of base. So that's what we're trying to figure out now. So our initial here is the 0.25 moles that I'm getting from our first table. A little bit of it is going to dissociate. It's a weak acid, so only a little will dissociate. And our change is going to be plus X for both the weak base and hydronium ion. So at equilibrium we have 0.25 minus X for our weak acid, we have X for our weak base, and we have X for H3O+. I'm going to now assume that X is small, so that 0.25 minus X is approximately 0.25 mole. Now we need to convert into concentration. So if we look back at our question, our total volume is 250 milliliters plus 100 milliliters, so that's a total of 0.35 liters. So down here, when we write our Ka equation, we have that it's equal to the concentration of base times the concentration of H3O+ over the concentration of formic acid. So this is equal to our concentration of base. So I'm going to say the concentration of base is equal to X over this 0.35 liters. I'm just going to call that a new variable Y. And that's the exact same as the concentration for our H3O+. So here we just have Y squared over 0.25 over 0.35 liters. So this is moles, that many liters. Our Ka is also just equal to 10 to the power of negative 3.75, which is using the conversion that pKa equals negative log of Ka, and the pKa of 3.75 was given to us in the initial question. Solving for y, we find that y is equal to the square root of 10 to the power of negative 3.75 times 0.25 over 0.35 molar. Plugging that into our calculator, we get that y is equal to 0.011 molar, which is our concentration of H3O plus from this table. So X was the number of moles, and we converted it into a concentration by dividing by 0.35 liters here. So we've just solved for a concentration of H3O plus. The original question wanted the pH, which is equal to the negative log of the concentration of H3O plus. So that's equal to the negative log of 0.011 molar, which is simply 1.95. So our pH of the solution is 1.95. So that's how you'd solve a question where you add an equimolar amount of a strong acid to a weak base.